Welcome back. Today I'll be talking about sample spaces. Sample space is basically a set. As you know, there are two kinds of set. One is infinite and continuous set, and another one is finite and discrete set. For this slide, let's focus on discrete and finite set sample space. To explain this, we'll do an experiment. In this experiment, we'll use a special die called tetrahedral die which has four different faces, which has four faces. Usually a die have a six faces, but this tetrahedral die has a four faces. And in this experiment, we'll have two trials, and each trial will involve rolling a die. So we'll roll a die two times in this experiment. If that's the case, what is a question we can ask a question, what is the sample space for this experiment, right? So we'll create a sample space in following way. The first step is to create a matrix, a 4 by 4 matrix as shown in the graph on the screen. So x-axis involves the first row and y-axis involves the second row. So there are total number of 16 boxes in this matrix, each showing the potential outcome of the experiment. So let's say we do the first row. We'll take the result of the first row, and let's say we do the second row, and we'll take the note of the second result of the second row. Now we have a pair of numbers. We'll put the first number in x-axis. We'll put the first number in x-axis and second number in y-axis. For example, in the first row, let's say we got 1, and the second row, let's say we got 2. Then we'll mark this box with 1 comma 2. So we can say that this outcome has occurred. Now let's say there's a different outcome with sorry. Now let's say there's a different outcome with 2 comma 1. Those outcomes are related. They are very close to each other, but they are not same. They are distinguished by the order in which they occur. In the second one, the first row is 2 and second row is 1. So that's how we distinguish them. This means the first row is 1 and second row is 2, but this means first row is 2 and second row is 1. Even though the we have both roll and roll 2, but they occur in different sequence, and so they are distinct in this outcome space, sample space, and those outcomes are separated by a comma so that we know that they occur sequentially. Now, this experiment involves two different stages. The first stage is a trial of throwing dice first time, and second phase is a second trial of throwing dice second time. And we know that whenever we have experiment with the different independent stages, it can be described by using a tree. So this is a tree which you can see in a screen. Now, what you see on the left hand side of the tree is a root of the tree. This is called root of the tree. And on right hand side, the ends, there are 16 ends of the tree. This is called leaves of the tree. So we'll do the experiment again for the uh, to for tree model also. We'll do the same experiment. So experiment starts. We'll throw dice, and there are four different possibilities of the outcome of the first stage. Let's say we got result one of the after we throw the first dice. We follow this branch. Then we do the second roll and take a note of the result. And let's say we got two. Follow the branch and we got two. And we are at the end of the end of the tree, which is the leaf, and we note the outcome 1, 2. So this is the result when we do the first roll and second roll, and when we get 1 and 2 as a result of our rolls. We also see that the different outcome 2, 1 has a different location in this tree, which is this. We get a 2 in the first roll, and we get a 1 in the second roll. So this is 2, 1, and it has a different location in the tree. If we compare the first diagram and the second diagram, we can see that the first diagram have a 16 different possibilities, 4 by 4, 16. And if you look at the second tree, we also see that it has a 14 different possibilities, 1, 2, 3, 4. Similarly, this also has a 4 possibilities. This also has a 4 possibilities. This is a 4 possibilities. So 4 into 4 is 16 in this second diagram as well. Now, we have discussed about discrete and finite example. Now let's change our focus to continuous and infinite example. Similarly, as previous experiment, we'll do a different experiment this time. We'll throw a dart at a rectangular target, which is of size 1 by 1. Now let's assume that when we throw a dart at this rectangular target, it always lands within the target. It never goes out of the target. So when we throw the dart, once it hits the target, what we'll do is we'll record the x and y coordinate with a very high precision, such that the x and y are real numbers. So what we will have is a sample space of x and y where x is a real number and y is a real number, and which is infinite. between 0 and 1. So let's summarize quickly what we have discussed today. We talked about the sample spaces, and we gave example of discrete finite sample space using a tetrahedral die. And secondly, we talk about continuous infinite example using a rectangular target and throwing a dart at that target. Thank you so much.